Hey guys, today what we're going to be doing is looking at the proof of the Pythagorean Theorem. So as a reminder, what is the Pythagorean Theorem? The Pythagorean Theorem is a squared plus b squared equals c squared. And this is used to find the sides of a right triangle. So if I transform this into a right triangle really quickly, right triangle has 90 degrees. Your legs are A or B, it doesn't really matter, they can flip-flop, but your hypotenuse, the largest side, the side across from the 90-degree angle, is always going to be your C. Okay, so let's go ahead and jump here. As you can see, here's my right triangle, and here's are the squares that are attached to it. So it says I want to find the side lengths to all of these. Well, first thing what we need to do, remember, a squared plus b squared is equal to c squared. What that is saying is the area of this squared plus the area of this squared is going to equal the area of this square. So 8 plus b is going to equal 16. So 8 plus mystery amount is going to equal 16. So that means if I minus 8 on both sides, this would give me the mystery square is equal to 8. Alright, so now that we figured that out, and that makes sense, 8 plus 8 is 16. I want to figure out these side lengths. So in order, what we did on the previous lessons, in order to get the area of a square to side lengths, what I do is I take the square root of these. So the square root of 16 is 4, therefore the side length is 1, 2, 3, 4. Hey, look at that. Now, these ones are kind of hard to count because they're like diagonals. So all we do is take the square root of the area. The square root of 8 is radical 8, and that'll simplify to 4 and 2, 2 and 2, where I have 2 radical 2. So my legs are both 2 radical 2, while my hypotenuse is 4. So what we're going to do now is we're going to prove that with the Pythagorean Theorem. If I did all my math correct, when I do a squared plus b squared equals c squared, I will get a true statement. So a squared plus b squared equals c squared. Let's plug these in. My legs were 2 radical 2 squared plus 2 radical 2 squared equals 4 squared. Now remember, when we distribute this, we distribute it to both this number and the radical. So 2 to the second power is 4. Radical 2 times radical 2. The 2 and the radical cancel, so that's 2. And 4 times 2 is 8. Plus, same idea here, 2 times 2 is 4, radical 2 times 2 is, radical 2 times radical 2 is 2, and 4 times 2 is 8, and 4 times 4 is 16, and then when I combine these, I get a true statement of 16 equals 16. So that's how you verify it using the Pythagorean Theorem. You plug in everything you know and see if you get a true statement. Alright, so let's go ahead now and look at the next one. It says, without a ruler, use your knowledge of right triangles and Pythagorean theorem to construct the following objects. Clearly label each object and the vertices. Write the slope of each line segment. So what it's saying is, I want you to write an area of 29. Now the hard part of that is area of 29 is not a perfect square. So it's going to be rotated a certain way. So how are we going to do that? We're going to look at our perfect squares, if we remember that. The square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, so on and so forth. And you want to see which two of these numbers could I add up and get a value of 29. And that would be the square root of the square root of 4 and the square root of 25. So what this is saying is, I have a side length of 2 and a side length of 5. So if we were to do this, let me go ahead and bring up these squares. If I had a square of, let me change the color. If I had a square that had an area of 4, let me change it one more time. An area of 4, it would have a side length of 2. Hopefully I can get this. There we go. Okay. And then the next one attached to it, I would have an area of 5. So 1 of 25. Okay, sorry about that. So then this value connecting the two would be part of my square. Okay, so how are we going to continue to make this square? Well, you see how I went up 2 over 5? What I'm going to do is now go over 2 and then down 5. 1, 2, 3, 4, 5. And then I'm going to connect these two. And then since I went down 5, now what I'm going to do is I'm going to go down 2. 1, 2, and then over 1, 2, 3, 4, 5. And I'm going to connect these two now. And my last step is I'm going to go over 2, 1, 2, and then I'm going to go down 5 to here. And finally, I'm going to connect these two. And as you can see now, I have my area of 29. Because remember, the area of b squared plus the area of a squared is going to add up to the area of c squared. So if this is the area of 25 and this is the area of 4, 4 plus 25 is 29. One more time, how did I do that? I found these square roots and I said, okay, the square root of 4 is 2. This is 2. The square root of 25 is 5. So then you just go follow the pattern. It's always A, B, A, B, A, B. So I go up 2 over 5. Then I'm going to go over 2 down 5. Then down 2 to the left 5. And then over 2 up 5. So whatever those values are, they just keep flip-flopping until you get the square. And you connect all these hypotenuses. Okay? So let's go ahead and do that again. If I have radical 18 and I look at my square roots, the square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, which one of these could add up when you add it, which two of these when you add up will add up to 18? And that would be this one right here. So what we're going to do is take the square root of 9, the square root of radical 9 plus radical 9 is equal to radical 18. So that we're going to do is 3 and 3. So that means if I were to draw my rectangles here, excuse me, my squares, I'd have an area of 3, and I would have another area of 3. This value right here would be the beginning. This would be one side of my rectangle, okay? So this one's pretty easy enough because I have a side length of 3s. So I go to the left 3, up 3. And then for the next part of my, we just continue that pattern. So then I go up 3, to the right 3, 1, 2, 3, and then I connect these. And then I go to the right 3, 1, 2, 3, and then I go down 3, 1, 2, 3, and I connect these. And then continue that process down 3 to the left 3, and then connect these. So this would be, if this has an area of, if this is 3, this is 3, this is an area of 9, this has an area of 9, a squared plus b squared would equal c squared, which would be 18. So this has an area of 18. All right, so hopefully this helped. Ooh, I just noticed one thing. It says, I actually went way too far. It says EF that has a length of radical 18 units, not an area of 18 units. Well, now that I have my square, I just have to do one step. If I have an area of 18, how do I find the side length? I take the square root. So this right here is my answer because this is the side of my square. To find the side length, you just take the square root of radical 18, which is just radical 18. So these side lengths are radical 18. All right, so I hope this video helped. If you have any questions, please feel free to email me or your teacher.